Hello and welcome to today's physics class. For this class, we're talking about the concept of inductor. So in our last class, we spoke about the concept behind the components of an AC circuit. So for components of an AC circuit, there are three there. We have the resistor, the capacitor, and the inductor. So for this class, we're talking about the inductor. To watch our class on resistor and capacitor, I'll drop the link in the description of this video. So check the description of the video. You see a link to our previous class on resistor and capacitor, right? So let's discuss the concept of inductor, please. By definition, inductor is simply a device used for storing electricity, right? That's like definition for inductor. Aside that, it's important to note the SI unit for inductor. So the SI unit for inductor is given as Henry. So the SI unit for inductor of an inductance is given as Henry. So it's given as Henry. So Henry is simply the unit for inductor. We said ohms is used for resistor. Um, Farad is used for what, the capacitor, and Henry is for inductor. Aside that, note that at this point here, note the circuit symbol for an inductor. For resistor, the circuit symbol for resistor is something of this nature. This becomes the circuit symbol for resistor. For capacitor, something of this nature. And finally, for inductor now, the circuit symbol is given as this. So this becomes the circuit symbol for representing inductor, as you can see in front of you. All right, at this point here, after defining inductor and this, we have taken the SI unit for inductor and the circuit symbol, let's discuss something important called the arrangement of an inductor. All right, at this point here, let's discuss the concept behind the arrangement of an inductor. There are two distinct ways of arranging inductor. We have the series arrangement and the parallel arrangement. So let's start with discussing this one after the other, please. For the first one there, I have, what's it called? The series arrangement. We have the series arrangement as being the first method, or perhaps the first concept behind arrangement of inductor. The second one there is called the this becomes the second arrangement of inductor that we have here. So observe that for our very first class for resistor, capacitor, and now inductor, there are just two ways of arranging: series and what's parallel. So observe that similarity between those concepts. But when it comes to what's it called, for series, the resistor and inductor series are the same thing. The resistor and inductor parallel arrangement are the same thing. So note that the parallel arrangement and series arrangement for inductor and resistor are the same. But for what's it called, capacitor, the reverse is the case, right? So watch the previous classes on those topics and you understand them more better. All right, at this point here now, let's discuss this arrangement one after the other. Let's start the first one there, called the series arrangement. Let's discuss the first one, called the series arrangement. By definition, this is simply the end-to-end connection of an inductor. So when it comes to defining series arrangement, the key word there is end-to-end. So the end-to-end connection of an inductor is said to be what there is series arrangement. So as shown below, please draw the diagram, please. This becomes the diagram for representing an inductor arranged in series. So I have this diagram. This becomes the diagrammatical expression. Call it L1, L2, L3. This becomes the expression for series arrangement of inductor, as you can see in front of you. Note that at this point, note that for an inductor arranged in series, their exact equivalent inductance is given as L to be equal to L1 plus L2 plus L3. So this becomes the series mathematical arrangement of inductor, as you can see in front of you. Let us call the second one they call the parallel arrangement. For the parallel arrangement, this is simply definition, please. This is simply the side-by-side arrangement of inductor. So, as shown below. So, I'll draw a diagram for you here. So, when it comes to series arrangement, the keyword there is side by side. Sorry, end to end, please. This becomes what a side-by-side arrangement, as you can see below. So, draw this diagram here. Draw this diagram here. So, it becomes diagram for expressing what's it called? So, call this one here. Call here L1, L2, L3. So this becomes the arrangement of inductor in parallel, as you can see in front of you. All right. So for an inductor arranged in parallel, note that their equivalent inductance is given as 1 over L 1 over L to be equal to 1 over L1 plus 1 over L2 plus 1 over L3. So this becomes the numerical expression for inductor arranged in parallel, as you can see. All right, let's discuss one last thing and let's start solving past questions based on inductor. All right, at this point here, let's discuss energy stored by an inductor. It's important to note that the energy stored by an inductor is also called the work done by an inductor. So what is the mathematical expression for the work done, or perhaps energy stored by inductor? So W is simply the work done by an inductor, also called the energy stored by inductor, is given as Li squared. So this becomes the expression for calculating the energy stored by an inductor. So where L is called the inductor, measured in what? In Henry, and we have I as the current, measured in amperes. So I have these two stuff here. So at this point now, let's try to solve some problems and let's see how to apply this concept in the solvings of that problem. Welcome back. Example 1. 2 inductor L1 to be equal to 10 meter Henry and L2 to be equal to 20 meter Henry are connected in series. What is their equivalent, or perhaps what is their inductance of the circuit? So I'm giving two inductor there. I'm giving two inductor. One is called 10 meter Henry. The second one there is called 20 meter Henry. The key word I need there is what? The arrangement. They are arranged in series. So for that question there, solution. First is first. What am I given? So the given, I'm given that 2 inductor L1 has been equal to 10 meter Henry and L2 has been equal to 20 meter Henry. So these two are arranged in series. How do you solve it? You said for series arrangement, what do you do there? Add them in a linear sense. So from here now, for series arrangement, I'll have that L is equal to L1 plus L2. Why not L3? Because this one's L3. For this one, maybe just two values there. 2 inductor. So I have 2 inductor here. So from here, my inductor becomes L1 is given as 10 plus L2 is 20. Add them up, I'll have 30 meter Henry as my answer to this question here, using the idea of series arrangement of inductor. Let's look at the second question here and proceed from here. Second question says that a parallel circuit, listen up, a parallel circuit consists of three inductor. L1 has been equal to 10 meter Henry, L2 20 meter Henry, and L3 30 meter Henry. Find the total inductor of the circuit. So for that question there, I'm given three inductor and they are arranged in parallel. So what do you know there? So solution for that question there. Solution, I'm given that L1 is 10 meter Henry, L2 is 20 meter Henry, L3 is 30 meter Henry. These three here are arranged in parallel. So I will express them in this word there, in this form, right? I'll use this form to solve them. So using this form now, per se, let me just clean this place and use it this way. All right, from here now, I will record this formula for calculating what's it called, inductor, and arrange in parallel. So I'll have that I'm given L1, L2, L3. So substitute this value here. I'll have that 1 over L is equal to 1 over what's L1? Of course, 10 meter Henry plus 1 over what's L2? That's 20 plus 1 over what's L3 there? That's 30. All right, at this point here, I'm having fractions, several fractions here, and a positive sign between them. So what comes to mind? LCM. All right, at this point here, what's your next task? My next task is look for LCM here. Of course, I'm having 10, 20, and 30. If you use your primary idea of looking for LCM, you discover that your LCM here is 60. So from here, I have 1 over L is being equal to, I have my 60 as being my LCM. 60 in 10 gives what there? Gives 6. 6 times 1 will give 6 here. Put your plus sign down here. Divide 60 by 20. How about the 3, right? 3 times 1 will give 3 plus 60 divided 30. That will give about 2. Right? 2 times 1 will give 2. Add my numerator. Drop this one down. 1 over L is being equal to, add this one up there. 3 plus 6 plus 3. That's about 8. 8 plus 2. That's 10. 11, right? All right, I'll have 11 all over 6. So in this case now, I can invert. Take this one, invert. I'll take this L first over 1. Apply the same idea here. 60 over 11. The idea is now is that if I'm having 2 over 1, it's still 2. So L over 1 is still what there? Is still L, has been equal to 60 over 11. So my L here is simply the inductor. And we said inductor are basically measured in Henry. So and Henry. So my SI unit now becomes meter Henry. So I have meter Henry as the SI unit for the answer here. So this is how to solve problems using the idea of inductor. So see you in the next class. Do well to hit the bell icon, subscribe to this channel, and share to your friends and classmates. See you in our next class.